Good morning. So, if you have been, going along with me this whole time, we are in lesson 41, which is our very last one in fractions. If you haven't been following along, that's okay, because if we go back, we have to redo this anyway. Yay, so fun. So today's lesson, the objective is find and use a pattern to calculate the sum of all fractional parts between 0 and 1. And you're also supposed to share and critique how your partner's doing it or how other people are doing it. Obviously, we're not going to be doing that part. So 2 of the problems we're actually not even going to do. So even with this fun YouTube lessons, we're going to skip a couple. The very beginning of it, we are going to basically find a pattern and then figure out what the pattern is. And then on the back, I'm going to show you another way that we can do it too, which is kind of cool. This isn't really a lesson that you would use super often. I would say that you don't necessarily, like if I didn't teach you this lesson, you would still be fine on like the test if we were actually having tests, which we're not obviously right now. But it is kind of a cool thing to learn. And you're shaking your head at me, but it's true. So, because I did, when I taught it last year, I didn't quite get it at the beginning. And I was like, what am I doing? How is this helpful? But then I understood as time went on. All right, so we're going to start right with our problem set, which is what I usually do. But we have to find the sums. So it's going to seem really easy at the beginning, of course. And then we look at the back of it or the second page, however it was copied. And you're like, what? Okay, so what we want to do is kind of find like the easy things to add together. So a lot of you might look at these two and be like, oh, well, 1/3 and 2/3 is 3/3. Excellent. And 3/3 and 0/3 are 3/3. So when you add these two, you get 1. And when you add these two, you get 1. So our answer is 2. Right? Now, how do we show that if we wanted to actually show it? I mean, I like that part. I like doing those, and you'll see my brackets later. But you're doing 0/3 plus 3/3 plus 1/3 plus 2/3. We just showed like adding these together and adding these together, okay? This is plus, not multiply. So this is 3/3 plus 3/3. So it's 1 plus 1, which is 2. Would you have to show all of that? No, not really. Okay, so now we have B, 0/4 plus 1/4 plus 2/4 plus 3/4 plus 4/4. Okay, so these should all be pluses. We can say, oh, 0/4 plus 4/4 is 4/4. So that's what we're trying to do. We're trying to make one whole. 1/4 and 3/4, and then we're left with 2/4. So this is 1 and this is 1. That's how I like to show it. So 1 plus 1 is 2 and 2/4. You thought it was going to be a whole number, didn't you? It's not. Okay, so could you go down there and write 0/4 plus 4/4 in parentheses, and then plus 1/4 plus 3/4 in parentheses, and then plus 2/4? Absolutely. I did it actually on my paper that I did, but I didn't have a lot of room on the paper. And honestly, I'm not sure if you really, as long as you're showing it clearly, I think that's good enough. Some of you might want to write it all out, but that's perfectly fine. All right, so let's move on to C. We have 0/5 plus 1/5. This is what's going to take me the longest. Plus 2/5 plus 3/5 plus 4/5 plus 5/5. Okay, so let's find all of our fractions when added together will make one whole. So we know that 0/5 and 5/5 make one whole. 1/5 and 4/5 make one whole. 2 and 3 make one whole, right? 2/3 plus 3, wow. 2/5 plus 3/5 is 5/5. So do you see how I broke it down like this? And each time I added 2 more, I separated the lines basically so I can see. Now I can go back and say that's 1, and that's 1. 1, 2, 3 to give me 3 whole. No half this time. Do you see how I did that? 0/5 plus 5/5 is 1 whole. 1/5 plus 4/5 is 1 whole. 2/5 plus 3/5 is 1 whole. Okay. All right. So no half on this one. I wonder if the next one will be a half. Oh, I'm just going to be writing forever. This is where I missed the Promethean board, because then I could actually pull it up, you know, pull up the actual work. I mean, I could have printed this, and I actually have 2 copies of this really, but it's too small. You can't really see it. All right, so let's combine. Well, let's add our fractions to make one whole. 0, 6, and 6, 6 equals 1 whole. You know, that reminds me of actually, I'll do that after. When we do like the least common denominator. No, what were we doing when we were finding the factors of a number? Yeah. Anyway, I'm on a tangent. Okay, so 1 plus 5 is 6. So here's another 1 whole. We add these together to make 1 whole. 2, 6, and 4, 6. And then we're left with 3, 6. So we have 1 whole, 1 whole, 1 whole. 1, 2, 3. So it's 3 and 3, 6. Our last one was 2 and 2/4. See if you are figuring out a little pattern here at all. Maybe. The next one we have, so we're on E, we have 0/7 plus 1/7 plus 2/7, 3/7. That's just going to take me 8 million years. 4/7, 5/7, 6/7, and 7/7. Okay, let's add our fractions. 0/7 and 7/7 is 1 whole. 1/7 and 6/7 is 1 whole. Remember, you're just adding the numerators. 2/7 and 5/7 is 1 whole. 3/7 and 4/7 is 1 whole. So we have 1, 1, 1, 1, 1, 2, 3, 4. Now we're back to a whole number 4. It seems like every other is a whole number. Have you caught on, boys and girls? Did you notice anything? Are you bursting right now to tell me? And the dog wants to come in. We are on F. It just takes so long to write everything. Okay. Is this going to be a whole number, or is it going to be a mixed number? Start thinking about that. All right, 0/8 and 8/8 is 1 whole. 1/8 and 7/8 is 1 whole. 2/8 plus 6/8 is 1 whole. 3/8 plus 5/8 is 1 whole. 1, 1, 1, 1, 1, 2, 3, 4, 4 and 4/8. So, did you figure out what this pattern was? There are 2 different things to notice about this. When I was doing it, I noticed one thing right away, but I didn't notice the other thing for a little bit. So every time, if you look, boys and girls, at A, C, and E, if you wrote down the answers, A, C, and E all had whole numbers, right? And then B, D, and F all had a mixed number. What did you notice about the mixed number? We have 2 and 2/4. We have 3 and 3/6. And we have 4 and 4/8. Okay, so they went up, right? They increased, but what did you notice about this part? And I know you, and I know most of you probably noticed that all of these are equal to 1/2. Our fraction was in eighths, so that one's in eighths. Our fraction that we were adding were in sixths, and our fraction that we were adding were in fourths. But they are all equivalent to 1/2. So when I added fourths, I ended up having the whole number of 2. What's half of 4? 2. When I added my sixths, I ended up with a whole number of 3. Half of 6 is 3. When I added eighths, what's half of 8? 4. Now, why is it half? You know, you could just say, oh, okay, because it's half. It came down to, and this is what I didn't realize right away, the number of pairs we made. If we had 8 fractions, we were able to make 4 whole pairs. Or if we didn't actually have 8. Well, let me show you eighths again, because I kind of said that wrong. I know this is the long one, but plus 5 eighths. So it wasn't, oh, hold on, I can't talk and write sometimes. Okay, so how many did we actually have? 1, 2, 3, 4, 5, 6, 7, 8, 9, because we had that 0/8. So when you are adding eighths, you're actually adding 9 fractions together. Like I said, even though this one kind of doesn't count, but you end up having 4 pairs with 1 extra, because there really are 9. So it is always, so if you're adding ninths, you're actually adding 10 fractions. If you're adding 20ths, you're actually adding 21 fractions. That's 1 pair, 2 pairs, 3 pairs, 4 pairs. Okay, so we notice a lot of stuff on this. So why is it when I add thirds and when I add fours, this one always has the half and this one has the whole number? That's odd. That's even. But it comes down to how many you're adding. You know, so I'll do fifths. 0/5 plus 1/5 plus 2/5 plus 3/5 plus 4/5 plus 5/5. So how many? I know you want to say that we're adding 5 fractions, and we kind of sort of are, but we're not. We're actually adding 6. 1, 2, 3, 4, 5, 6. If we're adding 6, can we make them even? What? Can we put them in even groups? 6 can be split into 2 or into 3 even groups of 2. Here are my groups of 2. So even though it's the odd number, you actually have an even number of fractions that you're adding. I know I just blew your mind. It's okay if you don't fully get it. You might want to watch this actually more than once. This is going to be a longer one. But when you're adding an odd fraction, you actually have an even number of fractions to add together. So that's why it ends up being just a whole number and not the fraction with half. Okay, so that pretty much is the answer to number 2. Number 3, how would the sums change if the addition started with a unit fraction rather than 0? So instead of saying 0/5, I say 1/5. Would anything change? Well, when you're adding 0, you don't actually really do anything. So it wouldn't really change but we still write it anyway so we can put our fraction pairs together. And that's the important part. So now you're on, you flip it, you open, no, it's actually open. Sorry, because I have the same work as you. So number 4 says find the sums. It doesn't have the, 0 tenth, 1 tenth, 2 tenths, 3, it doesn't have the 3 tenths and 4 tenths. Now, could you write it out and do all of those factor pairs? Absolutely. There's another thing you can do. You could actually add all of the numerators. You can add every single one of the numerators together. If you did that, because I did it, you get 65. It took me a while, though, to figure out, not to figure out how to add them, but I actually wrote out all of the fractions. Oh my goodness, it took me a while. Is it going to be worth writing all of these out? Well, you know what? If you have some time on your hands, which most of us do, go for it. Is it something that you could do for all of the problems on this page? I wouldn't want to do that. So when we're adding tenths, we're actually adding 11 fractions, right? We can't exactly do half of 11, can we? So in your head, you should be thinking, oh, this one is not going to have a pair. Correct. So what is half of 10 then? 5. Is that going to work? Hold on. Let's see. 1 tenth and 9 tenths, 2 tenths. Yeah. 1, 2, 3, 4, 5. I added wrong in my work because what I did was I added all the numerators and I have the wrong answer in my work. And let's make sure that number 4. Yep. That's great. Well, at least I caught my own mistake. This is correct. What I was telling you was correct. Half of 10 is 5. And we know that because we have 11 fractions, we have that half left over. So our answer is actually 5 and 5 tenths. So what I did in my work, and you can't really see it, and I don't think I could get close enough for you to actually see it, is I actually added all of my numerators and I got 65 tenths, and then I converted it to a mixed number, but I added wrong. So this way is definitely better. It's not efficient though. And clearly for me, adding all my numerators together wasn't very efficient. So knowing the patterns definitely makes a little more sense. But I don't know where I went wrong, but I did. So next one, we have 12ths. So if we're adding 12ths, we are going to have how many pairs? So if we're adding 12ths, like 12, well, not 12 12ths, but just 12ths in general, well, my unit fraction would be 1/12, so I can do that, right? If we are adding 12ths, we are going to have 13 fractions that we are adding. Okay. Now 13 doesn't pair up, 12 pairs up. So what's half of 12? 6. So that middle one, that half, is not going to have a pair. So what is 1/2? So 1/2, when you're talking about 12ths, you can do 2 times 6. So you do 1 times 6. So the answer is 6 and 6/12. A little bit easier. Now again, if you don't memorize this, boys and girls, it's not going to hurt you at all. It's just kind of a cool, it's a cool, not trick, but it's almost like a cool math trick to learn. If you want to impress someone, be like, oh, I know how to add up 15 15ths with the sum of all the numbers. Anyway, so for C, I wrote out 0 15ths plus 1 15th plus 2 15ths. So I wrote all of them out. But you know what? I don't need to do that, right? 15/15. Well, I don't know why I'm writing that. So we're talking about 15ths, right? 15ths would have 16 fractions. Can you take half of 16? Yes, you can. If you split 16 into 2 groups, you would have 8 in each group. Now, why am I talking about half? Well, 16 fractions, picture them all spread out, all 16 of them. You would have 8 partners as you go in. So when you add up all those fractions, you get the whole number of 8. All right, 25ths. Oh my goodness gracious. Start with 0 25ths plus 1 25th. Guess what? I don't want to have to do all that work. So I say, okay, 25ths would have 26 fractions. It's always one more because we have our 0 25ths. Okay, so that's 26 fractions. So how many pairs could I get? I could get 13 pairs, and oh, there we go. The whole number of the pairs add up to one whole. So if you have 13 pairs, you have one whole. Look at that. A lot easier, wasn't it? Although I do like actually matching up the pairs, but 50ths, can you imagine writing all that out? I don't have enough room. So if we start with 0 50ths plus 1 50th, how many? No, honey, no. Charlie, he's got to wait a minute. So if I have 50ths, how many fractions am I going to have? I'm going to have 51 fractions. Okay, so that is not even, is it? Okay, how many pairs can I get? Half of 50 is I can get 25 pairs. Then I'm going to have that half left. That part in the middle I'm going to have left. What's half of 50? 25 50ths. You could say, well, we'll leave it at that. So look at that. We don't want to do that. Oh my goodness gracious. If you look at F now, oh, we got both dogs here. We have hundredths. Thank you. Sit down. So do you really want to write out 101 fractions? Because I certainly don't. So that means we have 101 fractions that we have to add together. I certainly do not want to do that. Now 101 can't be split into 2 even groups, but 100 can, right? So we have 50 pairs, 50 whole numbers. 0 hundredths and 100 100ths would be 1 pair. So we have 50 pairs, but we have one left over, don't we? We have that middle one left over. That means half. What means half when you're talking about hundredths? 50 hundredths. So 5 and 6 you're supposed to, well, 5 you're supposed to compare with a partner to see how you solved it. We clearly solved it this way, so we don't really do number 5 here. How can you apply this strategy to find the sum of the whole numbers from 0 to 1? Well, this is what we did. So 5 and 6 we don't even have to write anything because it pretty much is done for us. So again, don't worry if you didn't quite fully get that, but it would be good to go over it again because it's just a cool way of I don't know, knowing about fractions. I thought it was a cool ending to our whole module. Would this be on the test if we were having the test? No, but that doesn't mean, actually, I don't even know, I don't remember. But that doesn't mean that we can't learn it, right? All right, have a great day.